How did it get in here? I swear I threw it out.
We had to design an interface so that we got all the controls right for the robot.
We designed a main menu to navigate the maze, Bluetooth, and communication pages within the application. The UI design of the whole application follows the same theme with varying degrees of the purple color.
Initially, the robot wasn't moving straight due to noise and variations in the environment, which results in uneven set speeds for both motors. This results in it deviating from the intended straight path and was not able to rotate left and right properly.
The sensors were not giving us stable and precise readings as well.
The robot refused to communicate with the Android tablet or the PC. It kept refusing to connect and we were not able to control the robot.
Everything seemed fine till the end of the day. Then hell broke loose. There were instances where the algorithm would send the instructions for the robot to move right, but the robot would continue moving forward, bashing through the obstacles.
No way, we had started early around week 2 and implemented the A-star algorithm for the fastest part and left wall-hugging algorithm for exploration.
We also decided to ignore the right sensor values of the robot for the robot to do image recognition tasks to ensure the robot visits all cells and circle the obstacles.
We worked with the AMD tool to make sure all our communications and connections work well.
We referenced the Enjoy Bluetooth Chat project by Google for our Bluetooth connection. We were able to make the robot move in our maze.
The waypoint and the start point can be set on our app too. We were able to receive and send strings using Android Broadcast.
We fixed the communication by setting up Bluetooth and Wi-Fi module on the archive and connect our device to the robot. We tested with our laptop and phone and we were able to communicate well with the archive.
We used YOLO V4 model for the object detection and it worked perfectly fine with the camera. We were able to draw bounding boxes around the images and got great accuracy too.
We implemented PID closed-loop control for our motor. We even had to tune PID frequently to make sure our robot can move in the straight path. Piecewise functions were also added to improve accuracy of the sensors.
They were able to detect obstacles pretty accurately. We accounted for fluctuations in sensor readings. We finalized the overall structure of our robot to suit algorithms' needs.
Once we put all the subsystems together, that's when we started noticing something paranormal and we realized the ghost of Annabelle had taken over our robot.
When we tried to connect and communicate with the robot, the Bluetooth kept disconnecting.
Our application did not display the right strings and the robot could even move out of the boundary of the maze. It was like it was trying to escape.
We noticed that our motors and sensors started behaving very weirdly. Eventually, we realized many factors affect the straight line motion of our robot. This includes battery level, friction of the wheels and ball bearings, and center of gravity of the robot.
Another peculiar issue we faced was the program crashing and the robot ceasing to move when an obstacle block was placed in the rightmost corner of the arena.
We had to work closely with other subsystems and find a way to get control of our robot again. We discussed communication protocol with the Android and algorithm team and standardized the communication across the device. We integrate the object detection model with the algorithm to find the location of the image.
The subsystems were allowed to reconnect with the RPi without restarting the whole program in case of loss of connection. We also used multiprocessing instead of multi-threading, and it made our robot much faster.
We set the UUID of the Android to connect well with RPi.
We prevented the robot from escaping by implementing condition tracks. We also implemented tilt sensing as an alternative way to control the robot.
We had to do regular calibrations, and we implemented a few algorithms to ensure that the robot does not crash into obstacles, and it can correct itself after avoiding obstacles.
We implemented a reset functionality where the program does not have to be stopped or killed if we want to run the robot again.
To tackle any unexplored areas during exploration, the fastest path algorithm is used to ensure we get all 300 grids explored, before using the fastest path again back to the starting location. We also helped in implementing our key strategy, Operation UU, where the robot moves multiple steps and the wall of the arena is on the left side of the robot.
Thankfully, despite the roadblocks, sleepless nights, anxiety, and stress we faced, we managed to make it to the leaderboard